Hi, in this episode of Understanding the Rolling Motion series, we are going to discuss a new problem. So here's the problem that is given in front of us. We again have a rolling object, and if you have followed the previous episode, then you will see that it's again a problem of dynamics, and there's a force acting, but in the previous problem, the force was acting tangentially on the rolling object, but in this problem, the force is acting at its center of mass. The surface is rough, again take care of that, and it is given that it is the object is pure rolling. Alright, so we have this information already in front of us. The object is in pure rolling motion, and its radius is given as r, its mass and moment of inertia is already given to us, and what we have to find is its angular acceleration and its translational acceleration. So first of all, whatever is given in the problem, I'll draw the exact schematic of that thing on the whiteboard right here. So always have this habit, whatever is the question, always draw the schematic first of all. So here is the rolling object, and the force is acting on this, like this is the force that is acting, and its radius is given as r, its mass is m, moment of inertia is I, and it is rolling over a rough horizontal surface, right? Now, if it is pure rolling over a rough horizontal surface, I told you in previous problem also we discussed, this is a rough horizontal surface and it is pure rolling. Pure rolling means that it is not slipping. We have discussed this. And if it is not slipping, we understand that there is a possibility of friction being there. In fact, whenever two things do not slip over each other, it means that there is static friction there. And if it is static friction, we understand that static friction can take any value from 0 to mu n, that is its maximum value. So we don't know what value it is going to take, and nothing is given about it in the problem. So we have to assume friction as a variable force here. And if you have seen the previous problem, I told you that because we don't know friction, we also don't know its direction, that in what direction friction is acting. So we can assume any direction here, okay? So in previous problem, I had assumed the direction of friction to be forward. So in this problem, I'm going to take the direction of friction to be backwards. So this is how I have concluded about friction. This is a variable force. I don't know its value, and we have to find its translational acceleration A and angular acceleration alpha. So we already have two variables, right? And two variables must solve, two equations must solve two variables, but you understand that since there is one more variable that has come into picture now, that is friction, so now we have three variables and we need three equations. So what is our first strategy? What is our plan when we start solving this problem? So the first thing that we are going to do is that break this motion into two parts, alright, and deal them separately. So here I am breaking them in two parts. So this is the part of translation. So I'm only thinking that this is only translating with some acceleration A, right? And the force here is also acting here. Like in the previous problem, the force was acting tangentially, but in this problem, this is not the case. The force is acting exactly at the center of mass, alright? The mass is given as m. So, and then there is another force that is here, that is the force of friction. This is the case of pure translation. I have forgotten that this disc is rotating as well, right? It is going to have some translational acceleration A. Sorry, I just threw my marker away, so I'm going to get it. I'm back. So, alright. So I was saying that it is having some translational acceleration A as well as some angular acceleration alpha, but when I'm dealing with translation, I have forgotten that it is rotating. I'm just saying that this is the rolling object, whatever it is, and it is just translating. It is not changing its orientation, just moving in a straight line like this. Alright, so what is going to be equation? What is the equation of dynamics for the translating object? It is nothing but total force, that is here, if I consider this direction to be positive, then I will have to say total force is F minus F. So I will write F minus F is equal to ma. This is my equation of translation. Alright, now let me consider the part where it is just rotating. So I will only consider it having an angular acceleration of alpha. And again, what are the forces acting? So this is force acting F here, and this is the force of friction that is acting here, and its radius here is r. Now, I have here in this case I'm not considering the translation part, so it is just fixed about its center of mass and rotating here. That's all it's doing. So what is the dynamics equation for rotation, for pure rotation, for a pivoted body like this, for a body which is performing pure rotation like this? the equation of the dynamics equation is total torque is I alpha. So total torque will be, what will be the torque of this force about center of mass? That will be 0 because the force is passing through center of mass, right? So only friction is going to have torque. There is mg also acting, but normal is also acting. But you know that both mg and normal, both of them, they are passing through the center of mass, and that's why their torques will be 0 as well. So here only friction is going to have the torque. So the torque of friction is F into R, and you see that the direction of this torque is again clockwise. So the total torque is Fr, and that Fr is I alpha. So this is my second equation that I got from rotation. So I will write both these equations together. So the first equation that I got is F minus F is equal to ma. That's the first equation that I have taken from here, and the second equation is Fr is equal to I alpha. Now, how many variables? 2 variables already. I told you this friction also, we don't know the value, and I explained you why we don't know, because it is not slipping static friction. Static friction can have any value from 0 to mu, and so we don't know. So we just assume some value, and it's another variable in front of us. So we need one more equation because we have 3 variables right now. And I told you in previous problem, I told you the third equation always comes from, one equation will come from translation, one equation will come from rotation, and the third equation will always come from the condition of no slip. Remember, you have this information that this is not slipping. What is the meaning of not slipping here? That whatever is the acceleration of this point, same will be the acceleration or velocity of this point. I mean, acceleration or velocity of this point is equal to acceleration or velocity of this point. Here we are dealing in, here we have accelerations known. Here we are writing equations in terms of acceleration. So we'll focus on acceleration. So tell me, this is fixed ground. So what is its acceleration? Its acceleration is 0, right? And what is acceleration of this point? Now again, to find the acceleration of this point, we will consider again both what is acceleration of this point due to translation part, and what is acceleration of this point due to rotation part. Alright, so I'm drawing again here. So here, let's say if it is just translating with an acceleration A, only translating. We have done it so many times. If this is a rigid body translation, then all the points must have same acceleration. So this point is also going to have an acceleration of A. Alright, and similarly, if it is rotating with alpha, then if this is r, then we know that at this point there is going to be, due to this alpha, an acceleration of alpha in this direction. So this point A due to translation and alpha r due to rotation, so net is A minus alpha, you can see. So this point is A minus alpha because both of them are in different directions, so I'm taking this A minus alpha r. And now, because these 2 points are, it is given, it is rolling, pure rolling, so it is not slipping, it means acceleration of this point must be equal to acceleration of this point. So the third equation is A minus alpha r is equal to 0. That is my third equation. So this is it. Now you have 3 equations, 3 variables, and you have to solve. Rest is mathematics. So have a good day with maths.